So matrix diagrams show the relationship between objectives and methods, results and causes, and tasks and people. They provide information about the relationship, and they help to determine the strength of relationships between a grid of rows and columns. They provide importance to the task and method elements of the subject, and they help in organizing a large amount of inter-process related activities. So let's review the 5 types of matrix diagrams. The first one is an L-type matrix. This is where we compare one list against another, with one set of elements on the x-axis and another along the y-axis. Then we have the T-type matrix, and this compares one list against 2 others in pairs, with 2 sets of elements on the y-axis that are split by a set of elements on the x-axis. Then we have the X-type matrix, which compares 4 lists, each against 2 other lists, in pairs with 2 sets of elements on both the x and the y-axis. And then we have a Y-type matrix, which compares 3 lists, each against the other in pairs, with two L-type matrices joined at the y-axis. And then finally, we have the C-type matrix, which compares 3 lists against one another. A combination of 2 L-type matrices joined on the y-axis is a 3-dimensional space. So a matrix diagram is a great tool that can be used in something called the house of quality within our define phase. Or it can be separately used to organize the data and evaluate the strengths of relationships between our different data sets. So here I have a couple of different data sets. We have list 1 and list 2. And in list 1, we have items 1 through 5. And then in list 2, we have items A through E. So there's 5 items in each one of our lists. Consider each one of these items a particular data point. Now there is something called just a linear standard relationship, or a one-to-one relationship. This is where item 1 only has a relationship with item A, and item A only has a relationship with item 1. Same with item 2 to B, 3 to C, 4 to D, and 5 to E. The great thing about one-to-one relationships is that you only deal with 2 data points that have a single relationship. And that happens sometimes in real life. But reality looks more like this. Item 1 may have a relationship with item A. That could be true. But item A might also have a relationship with item 4. And then item 5 may have a relationship with item E, but also with item 2. And item 2 might have a relationship with B and also with 3. Well, 3 might have it with C and also with 1. We know that relationship. And item D might have a relationship with item 4 as well as item B. And that's a little bit more like reality, to where there's a multi-relational type of interaction between our data sets. And so when we look at something like this, unlike this, where it's really easy to see the direction of that relationship, here we really can't notice that relationship. And so we have to find an easier way to be able to categorize the data to see its relationships. So with this, we can build something called a matrix diagram. And it's really easy. So we're going to have our list 1 on this axis and our list 2 on the top. So here we have our item 1, item 2, item 3, item 4, and so on. And up here we have our items A, B, C, D, and E. Oh, not 5, E. So now we can start mapping out these relationships. So what we can do is we can start saying that item A and item 1 have a relationship. And then we can also say kind of the same thing here, right? And then we can also say that item E and item 1 have a relationship. So item 1 touches those 3 things. And then we can start creating other things and other relationships. kind of just like this. And then maybe this one has a relationship there and there, and then maybe we have a relationship here, here, and here. 5, we'll just say has a relationship there and there. So now we don't have to deal with this madness and this mess over here, because this is our dream state, but this is our reality. So now comes this particular point. Well, there's still an issue when we look at the relationships between our 1s through 5s and our A's through E's. And that's the relationship of I don't know how strong each of them are. Just because item 1 has 3 relationships doesn't negate the fact that item 5 or item 3 that only has 2 is stronger or weaker. We don't know that. So what we have to do is start evaluating each one of these relationships in a very singular mode. And to do that, we have to start creating some symbols. So the first one is we have to figure out if it's a strong relationship, a medium relationship, if I can spell, and a low relationship. Now, it doesn't matter what symbols you use, but let's say that a strong relationship is a filled-in circle, while a medium relationship is going to be a circle that is half filled in, and a low relationship is just going to be the empty circle. So as we start seeing things happen and we start really understanding the strengths of these relationships, we can start filling in a lot of these circles, right? We can start seeing where these relationships actually start to take place. Okay, that's awesome. That's cool. We got that. Well, now we have to find some sort of numerical expression for this. So I'm going to say that a strong relationship is worth 10, a medium relationship is worth 5, and a low relationship is worth 1. And then I just add them. So I have 10, I have 5, I have 1, so this one is 16. I have 10 and I have 5, so this one is 15. I have 16 here. I have 11 here, and I have 2 there. I do the same thing to the other side. So I have 16 over here, I have 11 here, I have 11 here, I have 10, 15, 16 here, and I have 6 here. And then it's just deciding which ones have the biggest numbers. Well, this is a huge one. This is pretty big. This one's pretty big. And that one's pretty big. So I know that my relationships between A and 1, C and 4 are probably where I need to spend the most of my time because of the value that it's come out to be. That's the purpose of a matrix diagram, is to really allow us to focus where to apply our resources based upon the strengths of relationships between those two lists or those two types of products or services. The Process Diagram Program Chart, or PDPC, is a method that is used to chart the course of events from the beginning of a process until the end goal. It also helps to prepare contingency plans, which is used before implementing the plan, and in case the plan must be completed on schedule or when the price of the failure is quite high. This concludes topic 4. In topic 5, we'll discuss business results for projects.